guys! Thanks for tuning in to another episode of the Idahoan Show, sort of in the style of ForgottenWeapons.com. I am obviously not Ian McCullum, but I do have something pretty cool to show you here today. On the table in front of me, I have not just one, not just a couple, but the entire set of developmental prototypes, as well as some early production models, of the standard pattern muzzleloader that was developed by Atomic Rifling and Creative Operations, LLC, right here in Idaho. Now, conceptually, these all work essentially the same way. It's a single-shot, muzzle-loading, percussion cap ignited rifle, and the hammer and trigger mechanisms are all pretty similar. So before we get into the developmental history and the subtle differences between these different rifles, let's dive right in and take one apart so I can show you how it works. Now, I would start by showing you the markings on this gun, but there aren't any. Muzzleloaders such as this are exempted from the definition of a firearm under federal law, so they are not required to be serialized from a standpoint of legal compliance, and so apparently markings was an area where Atomic Rifling and Creative Operations felt they could economize. The first step in disassembly is going to be to punch out the hammer pin. And so to do that, I'm first going to place a spacer ring underneath the receiver. And then we'll just knock that pin out. I'm using a punch that is specifically dimensioned for this gun, so it will drive the pin far enough through the receiver to free the hammer, but it will also leave it captive in the other side of the receiver, as you can see here. So now I can simply remove the hammer and then turn the gun upside down and drop out the spring and its attendant ball bearings, which I'm going to leave inside my spacer ring for safekeeping. Now I can go ahead and knock out the trigger pin and remove the trigger as well. The trigger guard is welded to the receiver, so the trigger can only come out through the top, the same way we took out the hammer. So now that I have removed the working bits from the receiver, it's pretty easy to show how this mechanism works. We have a single coil spring acting on both the hammer and the trigger through a pair of ball bearings, and the spring and bearings, when inside the receiver, are contained in a slot, so they are constrained to move in a linear path between these two components, while the hammer and trigger are free to rotate about their respective pins. Thus, if I pull the hammer back just a little bit, that would compress the spring just a little bit and cause the trigger to fall into the half-cock notch. At this point, the trigger is prevented from being pulled by the protrusion on that notch, and the hammer is also blocked from being driven forward should the gun be dropped or another source of external force applied to the hammer. Meanwhile, if the hammer is pulled all the way back to full cock, then the spring would be compressed significantly, and so when the trigger is pulled, it would release the hammer to drop forward and hit the percussion cap. If we wish to continue disassembly by removing the percussion cap nipple, we can do that either with a simple open-ended wrench or a dedicated nipple wrench, such as I have here. And then the nipple is simply threaded into the breech plug. So too, if we want to remove the breech plug, we can do that with an open-ended wrench, just by unthreading it. And there is our breech plug. At this point, our standard pattern muzzleloader is about as fully field stripped as it would ever need to be. Of course, if we wanted to remove the sight apertures, perhaps to switch apertures, if we wish to do that, We could do that simply by loosening the thumb nuts that secure the aperture screws and then unthreading the screws. But I believe that this particular prototype has already been sighted in, so I'm not going to mess with the sights here today. So too, if we wish to remove the wooden stock, we could do so by punching out the retention pins that hold the forestock and the buttstock in place, respectively. However, there's nothing mechanically functional underneath these wooden stocks that we would need access to, either for cleaning or maintenance or just to show you how it works, so I'm going to leave them in place. Reassembly is basically the reverse of disassembly, so I'm going to begin by threading in the breech plug. And now I will thread in the percussion cap nipple. Next, I will insert the trigger and try to line it up with the pinhole. May have to hold the trigger back just a little bit so that the ball bearings and spring do not fall out when we insert them. Then we can insert the hammer, similarly line it up with its appropriate pinhole. And that's about all there is to it. At its inception, the standard pattern muzzleloader and its development project was spawned by the realization on the part of company management that muzzleloaders, provided they meet certain criteria like not being readily convertible to fire modern ammunition, are largely exempted from federal firearms regulations. And so they thought to take advantage of this unregulated niche in the firearms industry by developing a whole lineup of new and innovative and unique and interesting muzzleloaders, of which the standard pattern was to be their first entry, their first example in this proposed lineup. Well, as they got into the project, they began to realize just how much work and expense is involved in developing even a relatively simple muzzleloader, and so they may have backed off somewhat on their ambitions. But before we get too far into our story, I think what we really need to do is go through these examples one at a time and let me show you their unique features, their differences, and talk a little bit about the function of each of these developmental prototypes, and I think that will give you a far better appreciation for the work that went into this development project than if I just try to talk through it at a high level. Now, I have these laid out as chronologically as possible, from right to left, or perhaps left to right from your perspective. And so, beginning on my right, we have a gun that is actually not a standard pattern muzzleloader. Instead, this is a percussion muzzleloading blunderbuss that was built as just sort of a personal project by a manager of atomic rifling and creative operations about a year and a half before the commencement of the standard pattern muzzleloader development project. The reason I include this, though, is that if we consider the fire control mechanism here, we have an inline percussion cap or percussion cap nipple. We have a hammer and trigger with a single spring acting between the hammer and trigger with ball bearings on the ends. And so the fire control mechanism is a very clear historical precursor to what would become the mechanism of the standard pattern muzzleloader. By midsummer of 2018, the first prototype standard pattern muzzleloader had been produced. This was originally envisioned as something that would be aesthetically intermediate between a historic replica muzzleloader and a modern inline muzzleloader. Now, this first prototype is probably best understood as a proof of concept. Obviously, there were some details like ramrod storage that had not really been addressed yet. In this case, the ramrod was obviously sort of cobbled together and then just strapped to the side of the finished gun. However, this does already embody a number of significant design and production milestones. The barrel is a .50 caliber rifled barrel that was produced in-house for the project. Barrel manufacturing capabilities were seen as an important precursor to muzzleloader manufacturing. The rear sight is already designed, or I should say that this design would continue throughout the muzzleloader development project with just some minor dimensional tweaks. Similarly, the hardwood stocks are secured to the barrel underlug and the receiver tang with cross pins, much as they would be throughout the standard pattern development process. Taking a close look at the fire control mechanism, you can see that this machined block has been added to the hammer, and that forms a shroud around the percussion cap nipple that will protect the shooter from any gases or percussion cap fragments that are blown back out of the nipple during firing. That was seen as an important improvement over the blunderbuss precursor in terms of safety and marketability. Also interesting to note is that this hammer actually rises as it is cocked. So by the time it hits the cap, it's actually swinging downward at a fairly significant angle. And this was done originally with the intent to simplify the design of the receiver side plates, keep them to a very simple geometry that would be easy and efficient to produce. Unfortunately, when the hammer hits the cap at that angle, it doesn't really set it off very reliably. In testing, it was found that this prototype was only about 50% reliable. You know, you'd load it up, put a cap on the nipple, go to fire it, and about 50% of the time it would go off. The other 50% you'd get a light strike. It would fail to set off the cap. And for that reason, this prototype earned the nickname of Flinch Fixer 500 in testing. 500 was simply a reference to the fact that it's .50 caliber. The flinch fixer, well, if you have a tendency to flinch when firing a gun, then if the gun fails to go off and you flinch, it will be painfully obvious to you and everyone else that you flinched, and seeing yourself do that a few times can help you to correct that tendency. So that is how it earned its nickname during testing. In the second prototype, the hammer design was modified significantly with corresponding changes to the trigger, so that the hammer would strike the cap at a much more direct angle, and this largely solved the problem with light strikes that had been observed in the first prototype. However, this mechanism was not without its faults. For one thing, as initially produced, the trigger pull was determined to be excessively stiff, and yet if the hammer was placed on half cock and the trigger pulled with sufficient force, the hammer would actually kick back a little bit, drop, and fire a cap if there were a cap on the nipple. So this was literally capable of going off half-cocked. And so while the light strike problem had been addressed, further refinement of the fire control mechanism was deemed necessary. Additionally, the stock on this prototype came all the way back to the rear of the receiver. That was only done on the second prototype because after doing it, it was realized that that rendered the hammer and trigger pins inaccessible, and so the stock had to be removed in order to remove the hammer and trigger for cleaning. That was determined to be undesirable, and so stocks were not made with that level of inletting after the second prototype. The ramrod on the second prototype was stored under the barrel, as would become standard. However, the second prototype actually featured a fiberglass ramrod, which would later be replaced by an aluminum one, although the pommel knob feature would be retained. The primary purpose of the third prototype was to finalize the hammer and trigger mechanism, and indeed the fire control mechanism was deemed acceptable in the third prototype. However, the third prototype also has a number of other interesting features that bear mentioning. For one thing, whereas the first two prototypes, as well as the blunderbuss, all featured welded-in, non-removable breech plugs, the third prototype features a threaded breech plug. However, there's this step feature in the receiver that was used to locate the barrel for welding so that the percussion cap nipple would be in the right place to be hit by the hammer, that prevents the breech plug from actually being unthreaded. Even though it is threaded in, it might as well be welded because there's no way that you're going to unthread it without destroying the receiver. So, while it was deemed desirable to go to a threaded breech plug design, the third prototype was sort of a transitional form where that implementation of the threaded breech plug was not really complete yet. Meanwhile, the third prototype also went off on kind of a tangent as a cavalry model carbine, in that it featured a single point sling of sorts, mocked up with this rope, that had a loop on it and a hook on the end of the barrel, so that in principle, a person who was hypothetically riding a horse or in some other situation where he needed to reload with one hand could suspend the rifle across his chest. Let me see if I can demonstrate this for you. And then he can operate the ramrod, which is captive and hinged at the front, and be able to reload one-handed. Now, in testing, it was found that this hinge mechanism for ramrod retention was somewhat finicky with regards to dimensional precision. If the dimensions weren't quite right, then the ramrod either would stick or wouldn't be able to go down the barrel. And so the degree of precision required for making these parts was deemed to make this system impractical or not likely to be cost-effective for production. And so as a part of the development project, the cavalry model was sort of a dead end. There was the one prototype that was made, and it was not pursued further. Now, while the design of the hammer and trigger mechanism had been finalized as of the third prototype, they still had to standardize the tooling that was used to make hammers and triggers. And it took 2 more prototypes to work the bugs out of the production tooling. So that was the primary reason for producing prototypes 4 and 5, was simply finalizing the design of the production tooling for making hammers and triggers. However, once again, with these prototypes that had to be produced anyway, they went off on an interesting tangential development path with experimenting with folding stocks. So here on the 4th prototype, we have a stock that pivots actually in the middle of the receiver tang underneath these rather diminutive wooden grip scales. And so if we pull this pin, that allows us to rotate the stock 180 degrees, at which point we can reinsert the pin there. And now this is folded up into a pretty compact package. To deploy the stock would be just the reverse, where we pull the pin, rotate the stock, and then reinsert it. This worked well enough that it generated some interest in the folding stock concept. However, this particular design was kind of floppy, potentially kind of flimsy, and was ultimately not deemed suitable for mass production. Of course, the 4th prototype was also the first prototype to be fitted with the final ramrod design, namely the solid aluminum rod with a brass end effector threaded into one end and a pommel knob threaded into the other. And while the ramrod is stored under the barrel, it is actually still secured simply by an industrial-grade rubber band. The next prototype featured a rather different folding stock design. In this case, there is a pistol grip that is pinned directly to the receiver tang, along with this hub mechanism that supports a folding arm for the stock. In this case, to fold the stock, I have to compress this spring, pulling this pin out of the detents into which it is locked. The spring, by the way, is very stiff, but then I can rotate that around until it clicks into place, and that makes a very compact muzzleloader with kind of a quasi foregrip when the stock is folded. To deploy the stock, I can simply push in on the stock retention column there and then pull it out until it clicks into place. And this actually provides a very stable and secure stock for this muzzleloader. Now, that said, about this time, it was determined that with all the work that still needed to be done, and because the project was taking longer than expected, the folding stock would not be pursued further as part of the initial development. It was sort of set aside for further refinement and finalization after they were into production with the standard model and making some money. So the folding stock was not taken any further than this during the initial development of the standard pattern muzzleloader, but it is still interesting to see these first 2 initial conceptual prototypes of what that folding stock might look like when and if it ever goes into final production. So at this point, the company has a design that basically seems to work. They have tooling to produce that design, at least in very small quantities, but there's still a lot of unanswered questions about things like long-term reliability, wear resistance, accuracy, and safety that really need to be addressed before they can responsibly take this design to market. And so, while the design was pretty well finalized from this point forward, there were still a bunch of developmental guns that were made to facilitate different parts of the testing that was deemed necessary before this gun could be introduced onto the market. Of course, the first issue that needed to be addressed was safety. You know, they'd been proof testing barrels all along, and so they had a reasonable assurance that these guns were not going to blow up in normal service. But there's always the question of, well, what if somebody double charges it? Or what if they forget to remove the ramrod from the barrel before firing? You know, at the very least, in order to responsibly put a product like this on the market, you need to understand what would be the likely outcome of some of these potential hazards so that you can advise your customers accordingly in the user manual or other applicable literature. So, they went ahead and built another prototype specifically for destructive testing. This is very much intended to be a standard pattern muzzleloader, except for the fact that it was never furnished with a stock. And the reason for that was that it was never to be fired by hand. Instead, this would be clamped in a vise or otherwise secured such that it could be fired remotely, and then in safe and controlled conditions, it was subjected to a variety of overload scenarios to see what would happen. Now, you may notice that the muzzle of this looks kind of funny. It's flared like a blunderbuss, but it's all uneven and it's missing the front sight. Well, that's because a severe overload combined with a serious bore obstruction succeeded in blowing off a couple inches of the end of the barrel. Other than that, however, the gun survived all of the abuse to which it was subjected in remarkably good condition. And so this was deemed to have a very satisfactory margin of safety against most overload scenarios that might realistically be encountered due to human error. The next concern that needed to be addressed was accuracy. You know, what kind of accuracy can we realistically expect from a standard pattern muzzleloader? And so, to facilitate extensive accuracy testing, they built this. This was intended to be a standard pattern muzzleloader with the exception that instead of a normal rear sight, it featured a rail to which a scope was mounted, simply to eliminate a certain measure of human error during testing by allowing the shooter to see the target a little bit better. However, during production of this unit for accuracy testing, it was discovered that if the tooling for drilling the pinholes in the receiver was not set up quite correctly, these holes could migrate about 3/4 of an inch forward. Still be in the same position relative to each other, so the mechanism would still work, but everything would be offset a little bit toward the front of the receiver. And that's exactly what we see in this example. In fact, you can see the original guide hole for the mainspring and its terminal bearings is empty back here, and a new hole had to be drilled, further forward to accommodate the displacement of the mechanism. And then there's also this cutout that had to be made in the top of the receiver, much like some of the earlier prototypes, to accommodate this shroud block on the hammer so that it can be cocked all the way without interfering with the receiver side plates. So that slight discrepancy was actually just an error in producing this particular example, but it was an error that was deemed not to be significant in terms of how it would affect the accuracy of the gun. Mechanism still works the same. the displacement really shouldn't have any effect on the accuracy, and so this was used for extensive testing. Now, the results of the accuracy testing were not quite as flattering as the results of the overload testing were. The ultimate conclusion was that they could only guarantee about 10 minutes of angle accuracy using ammunition that would be normally used for muzzleloader hunting. Things like loose Pyrodex as a propellant and patched round balls or, hand-cast mini balls, that sort of thing. If this was tested with saboted bullets or, jacketed projectiles, I'm not aware of any record of that testing, at least not during the initial development of the standard pattern muzzleloader. After accuracy testing came endurance testing. And for that, 4 more prototypes were constructed. 2 of them were rifle length, 2 of them were carbine length, 2 of them were left in the white, and 2 of them were flame blued. These were subjected to an extended course of fire, and the number of rounds through each was deliberately staggered so that the degree of wear at different stages of use could be readily compared. This one was subjected to the most extensive course of fire. It sustained a little more than 1,000 rounds, which did little more than polish the bore as far as wear on metal components was concerned. The one failure that was observed was that about halfway through the testing, a crack developed in the stock that had to be glued back together to prevent the stock from separating and flexing during firing. So perhaps this particular style of pistol grip stock is not strong enough to sustain repeated recoil of a 50 caliber muzzleloader over an extended course of fire, but other than that, the wear was deemed acceptable on all of these prototypes that were subjected to endurance testing. With the completion of endurance testing, Atomic Rifling and Creative Operations was finally getting close to being ready for market introduction. And so here we have the first batch of early production units. Some of these were produced as 90% kits. So, this is a mechanically functional standard pattern muzzleloader, but it still needs a stock. The metal is left in the white, the front sight has not yet been contoured, so all of those aesthetic details are left to be finished out by the end user or some intermediate dealer who has the skills and the desire to finish or personalize or customize it as they see fit. Others, of course, were produced as finished muzzleloaders, much like some of the prototypes with hardwood stocks. And this rather unique unit was finished out with metal tubing welded to the receiver for the stock and then wrapped in paracord, furnished with a green powder coat finish on the exposed metal. This was produced mostly just to demonstrate how aesthetically versatile the standard pattern muzzleloader design is. So while the hardwood stocks are expected to be probably the preferred design or the preferred embodiment of the design, the paracord tacticool look is certainly possible with this design as well. Now, at the time that I'm filming this, Atomic Rifling and Creative Operations LLC is still gearing up for their initial market release. And so the ultimate commercial success or failure of the standard pattern muzzleloader remains to be seen. For that matter, the fate of many of the guns on this table has yet to be decided. Obviously, the company hopes to sell off most of the production units. Some of the prototypes could eventually be sold off as well. But I thought it was pretty cool to get a chance to film this while all of these are still together in one place, and I can spread out the physical embodiment of the developmental history of this design all on one table to bring to you guys. So, hope you enjoyed the video. Thanks for watching.